Hello, this first video covers the slide 12. It's a practical demonstration about the work environment and the Glasgow Haskell interpreter that we'll be using in our lectures. The presentation covers some more general information about functional style of programming or about functional programming paradigm. You can study them in this presentation. These slides won't be covered. Uh, Maybe some basic information. So functional style of programming belongs to declarative style of programming. It's a sort of opposite to imperative programming. Uh, Imperative programming you will be using in programming 1, where you can learn how to write programs in C or C++. Maybe the basic differences can be summarized as in functional programming, a program is a sequence of, or it's rather an expression that is composed from functions, and evaluation of this expression is the evaluation of the program. On the other hand, in imperative programming, a program is a sequence of commands or a sequence of statements that are performed. Maybe the functional programming can be said that functional programming is closer to math. So some terms from math have their original meaning. For example, a function is still a function in this pure functional programming languages. Uh, Functional programming have a lot of good properties. These functions are a very nice abstraction mechanism, high order functions composition. So we can write, let's say, elegant and concise program. Usually they are shorter than their imperative counterparts. Usually these pure functional programming languages have a stronger, better from this perspective type system, so they are more error prone. It's much harder to, for example, produce some sort of runtime error. There are some new possibilities like lazy evaluation and so on. Later we'll be talking about them. From this perspective, if you want to characterize, if you want to define this functional programming, we can say that the program is composed from functions and only functions. These functions have no side effects, so based on the input, they produce some output, and this is the only effect, the only outcome of the function. And we need to add that there are immutable data structures. So once the data are created, they cannot be really changed. We can create a new data based on these old data, but we cannot change the old data. There are some, so these are some advantages. There are, of course, some disadvantages. So, for example, some operations like debugging are, let's say, harder to perform, or maybe the most crucial or the basic some obstacle to use functional programming languages is their performance. So sometimes they are much slower than their imperative counterpart, and some very advanced optimizations or some very advanced optimizations need to be performed, or we need to remove some things, for example, like this lazy evaluation. These purely functional programming languages like Haskell that we will be using are not that frequently used in practical applications. Maybe the biggest project that I have found is Facebook anti-spam filter or anti-spam engine. But this functional style of programming that will be the focus of this subject can be in fact used in any language. So even in imperative C++ language, you can use the functional style of programming. And there are some very popular programming languages that can be said that they are mostly functional. A lot of these popular programming languages are multi-paradigm programming languages, so they implement more than one programming paradigm, And for languages like JavaScript, Python, maybe even a C Sharp, we can say they are mostly functional programming languages. In our lectures, we'll be using programming language Haskell. Haskell is, let's say, a very nice programming language because it's quite popular, pure functional programming language. On the other hand, it's not that popular, so still some changes can be made. And from this perspective, it's a mature programming language with plenty of tools. And let's say, similarly to other pure functional programming languages, is very simple on this syntax and semantic level. So the language is very, let's say, short compared to other languages like C++. So only a few keywords, some basic construct like the ability to write the functions, but nothing more. And so it's very easy to learn this programming language. In our case, we mainly focus on this functional style of programming, and we will be using this pure functional programming language because these principles are exposed in this programming language. So there is no other way how to solve it than this pure functional way of programming. On the other hand, in our lecture, we won't cover this, let's say, more advanced topics. So if we want to really learn programming language like Haskell, so probably we will learn some syntax, some semantics of basic constructs from the language, but most times we will be learning how to use different API functions, how to use this language to, I don't know, connect to the database, open files, and so on. So this part won't be a focus of our lecture. Our focus will be primarily on this functional style of programming, and not really this subject won't be really about Haskell and how to write some more advanced programs in Haskell. So from the API, we will be using only some basic functions and nothing more. If you want to write a program in Haskell, so what we will be writing? As I said, it's functional programming, so the most basic unit is function. So in our case, we'll be writing programs that will compose from functions, and then we will try these functions. As in other languages, also here, we need a compiler to compile our source codes into something, into some form that can be executed on target platform. For Haskell, the best compiler is Glasgow Haskell compiler. In our case, we'll be using, let's say, a variant of this compiler, Glasgow Haskell interpreter. As you can see from the name, it's an interpreter that takes some expression and evaluates this expression. So our main, let's say, sort of work scenario will be that we will write some simple functions in Haskell and then we load them into this interpreter, and directly from the interpreter we will try them and see if they are working and if they are computing what we want. In this first task, I want to show you, or in this first video, I want to show you which tools we will be using. So for the compiler part, as I said, we will be using Glasgow Haskell compiler. The part will be using interpreter of this compiler, and our source codes will be written in Visual Studio Code. There are some other environments that can be used for Haskell, but so this Visual Studio Code may not be the perfect one, but it is present in computer laboratories, and it will be used also in other subjects related to programming. So if you learn how to work with this environment, you can use the same environment for other lectures. This Visual Studio Code can be modified based on the language that you are using. So in our case, we will need some plugin that will enable the Haskell programming in Visual Studio Code, and the plugin will be named Haskell. What I will show you is some sort of practical demonstration how to install the environment and how to work with this environment. All this information are present on my web pages, so there is a section software, and here you can directly click on the links for these tools. So first of all, we need to download and install Visual Studio Code. Here you can see the web page where you can download it for your platform, and if you install it and run it, here you can see on the background here you can see the started Visual Studio Code. Second, what you need is Haskell platform. A Haskell platform or Glasgow Haskell compiler. Haskell platform, Glasgow Haskell compiler can be downloaded from web pages haskell.org. There are some guidelines what you can do or what you should do. Let me show you. So if I use this tool Choco that is referenced in this guide, then I can install this Glasgow Haskell compiler. The sequence of commands that you need to perform is also present in this installation guide. Here it's this command, so you can install some sort of some version of the Glasgow Haskell compiler. The version is not that important, but later we'll be using a plugin for Visual Studio Code. So if I check my installed plugins, one of them is Haskell, and here you can see which versions of Glasgow Haskell compiler are supported. In this case, for Windows, for example, a good choice right now in the time when this video was created is version 8.10.5. So in this installation guide, what I can do is install the version 8.10.5. I already have this version. If you install this Glasgow Haskell compiler without any version and you want to check which version you have, you can write Glasgow Haskell compiler GHC and like a parameter version. So you can see that I have this version already installed in my system. Nearly the same approach can be used, for example, for Ubuntu. Again, on computer laboratories, you will have Windows and Ubuntu, so you can prepare the same work environment. And also here, you can use this apt or aptitude or something to install this Haskell platform or directly this Glasgow Haskell compiler. So, if you have installed this Glasgow Haskell compiler, again, you can check which version you have. In my case, what was present in this packages of Ubuntu, it was version 8.6.5 that is also supported by this plugin. So you can use this compiler along with this Visual Studio Code and plugin Haskell. If you have installed the Visual Studio Code, Glasgow Haskell compiler, and its Haskell plugin, then your environment is in fact set for programming in Haskell. In this case, you need to create a file with extension hs, and then you can write some functions into that file. For example, a simple function plus that gets to number and produce their sum. So I can add together these two numbers. if everything is working, so you can see here that the function, the compiler or this plugin used the compiler to compute a type of this function. So in our case, it's some line containing num a and then 3 a's. We can try it. In our case, we'll be using this Glasgow Haskell interpreter. Before I checked the version of Glasgow Haskell compiler if you want to run this Glasgow Haskell interpreter. So I'm writing this command, so E at the end, and then the interpreter is started. There are some commands for the interpreter. It follows this Linux style. So if you write a column and then, for example, help, some sort of help will be written on the standard output. The most basic commands that we will be using are load, reload, or quit. In this case, you can write only first letter. So the same is if you want to, for example, load a file, you can write column L or column load. Because it's an interpreter, so it interprets the or evaluates the expression written in Haskell. So for example, Haskell have a function length that writes length of some list. So you can see that if I write this expression, then it's directly evaluated using this Glasgow Haskell interpreter. If I want to try my function plus, I can load the file name, or I can load the file providing its file name. In my case, it's a video.hs, and after it is loaded, I can try the function plus and, for example, add together two numbers like 4 and 5. In my case, you can see that everything is working because I was in the same directory where I had this file. This thing still works, so you need to provide the full path to your file or be in the same directory when you have started the Glasgow Haskell interpreter as you have this file. So if you followed all these steps, you have Glasgow Haskell compiler and interpreter installed on your system. You have Visual Studio Code, and you have downloaded this Haskell plugin into Visual Studio Code. Now you are able to create some source codes, some input files for Haskell. This input file will consist of some functions, and you can directly try them in this Glasgow Haskell interpreter.